Okay, in this video, we're going to work some problems where we solve right triangles. We do what's called solving a triangle, and specifically these are going to be right triangles. And so the idea is to solve a right triangle, you have some information about the triangle, some combination of side lengths and angles, and the goal is to find all of the missing information. So you want to find all of the angles of the right triangle and all of the side lengths. Then you've solved it. Okay. Now, the textbook wants us to track the significant digits and then give the final answer with the correct number of significant digits, but we're not going to do that. And the reason is because to me, especially once we get into the applications problems coming up in the next videos, I think it's too much. You're already learning trigonometry. The whole purpose of this is to learn trigonometry, so you don't really understand the trigonometry, obviously, or you wouldn't be taking this course. Then you have to, for the applications problems, you're trying to conceptualize the application, and then you're going to add on to that significant digits. To me, it's too much. So all we're going to do is we're going to just, for each calculation, we're going to just keep the maximum number of digits that the calculator can hold, and then bring that all the way to the final answer. And then we're just going to write the final answer with like the maximum number of digits. And then the idea would be that if you were tracking significant digits, then you would round that final answer, but we're not going to round the final answer. Okay, let's get started. We've got, so we don't know this side length, we don't know this side length. We know the hypotenuse, and they give us this angle. So obviously we can find angle B here with just the fact that the sum of the angles needs to be 90 or 180 degrees. But we could use trigonometry to find this unknown angle too, but let's just, that's really easy. So let's go ahead and do, so it will have 180 minus 90. Well, yeah, so we know that these two angles, the two angles of a right triangle that aren't the 90 degree angle, are complementary. So this is going to be 90 minus A. So angle B is 90 degrees minus 36 degrees, 20 minutes. Okay, so what is this? How do we do this? Well, in chapter, I think it was chapter 1, we did a bunch of calculations like this, and the idea is, so 90 minus 36 is what? So we're going to get to 54 degrees, but then we go 20 minutes, we go further 20 minutes. So angle B is going to be not 54, but 53 degrees, and then 20 minutes off of the 54 would mean that we're left with 40 minutes, right? 60 minutes to a degree. So you subtract off 36 degrees, you get to 54 degrees, then you subtract off 20 minutes, so you go 53 degrees, 40 minutes. So this is 53 degrees, 40 minutes. There we go. Okay, now we can use trigonometry to get the one or both of the side lengths. We can get one side length and then do the Pythagorean theorem if we want. I'm sure calculators, you could input minutes somehow, but it would be easier to, let's just go ahead and convert one of these to the decimal form, so we can input that as the decimal form into the calculator. So, okay, angle B would be, so this is 53 point, and then there's 60 minutes in a degree, so 40 divided by 60 is 4/6, that's 2/3. So 53 and 2/3, which is, 0.666, evil number. Okay. 6, 7, but let's just, we're going to carry, let's try and get the final answer to as many decimal places as possible. So let's actually use the exact answer. But we're not tracking significant digits, so we're going to actually, there's the exact answer. All right, so now what we're going to do is let's take the cosine or the sine of B to find lowercase a or b. So we could do, let's just do cosine. So cosine of 53 and 2/3 degrees is equal to the adjacent over the hypotenuse. So A is, all right, so 53 and 2/3. 53 times 3 plus 2, so 161 divided by 3. So we're in degree mode, so we're going to do cosine of 161 divided by 3. Well, let's actually leave that exact for the moment. Times 964. So that's the exact answer, because it can't compute. You know, this is, it can't like simplify this, the sine of 161 over 3 anymore. So we're going to get the approximation. So 57.153. So we'll just put the maximum number of digits here. That's A. Well, let me just come out here. So A is 57.153. Or no, 571.153 meters. Okay, so now we could use the Pythagorean theorem, or we could take the sine of this or the cosine of this. So let's just use the Pythagorean theorem. So we've got it's so a squared plus b squared is equal to 964 squared. So we know that b squared is equal to 964 squared minus a squared, right? So what we do is we say 964 squared minus, there's a squared, and then take the square root of this. And we're carrying all those digits, right? 776.583. meters. And there you go. We now know every angle and every side length. Okay, now I made a mistake. Why did I put sine here? Or did I? So, okay, wait. 53 times 3. 159 plus 2, that's 161. So this is 161 divided by 3. So we do cosine 161 divided by 3. That's adjacent over hypotenuse, so then we multiply that times the hypotenuse. 571.153. And then Pythagorean theorem, 964 squared minus 776.583. Yeah, and then the idea is so these are like the nominal answers, and then what you would do is you would go back and do the whole tolerance stack up and then do the appropriate rounding. But you don't want to you don't want to round at each step, because then you have to have like a rounding stack up. The only reason you're rounding is because you don't want to report to a higher accuracy than anything you measured, than any the weakest link of the chain that you measured. But you do all the calculations with like the nominal values in the highest precision you can first with the calculator, and then you get that final answer that's like way more accurate and perfect than it should be reported, and you round that. You see. But again, don't get bogged down with significant digits and rounding. And this is all, if you understand how we just solved this right triangle, regardless of the rounding and everything like that, then you're fine. Then you're perfectly fine for this course. Okay, so let's just go ahead and get this other angle. So these two are complementary. So what is 90 minus 51.2. So 10 minus 2 is 8. 9 minus 1 is 8. 8 minus 5 is 3. So this is 38.3 degrees. Or no, 38.8 degrees. Okay, so we can pick any trig function in any angle. So let's do cosine of 51.2. So the cosine of 51.2 degrees is equal to adjacent over hypotenuse. Why don't we, to make it easier, it doesn't matter. I'm just trying to show you the different perspectives. Why don't we do the inverse of cosine? So secant of 51.2 degrees. So secant is not the inverse, the reciprocal of cosine. Cosine is adjacent over hypotenuse. So we have hypotenuse over adjacent. So now we just all we have to do is cross multiply. P is 124 times secant of 51.2 degrees. So P is, so we've got secant 51.2, we're in degree mode, you can see it's in degree mode, times 124, 197.892 meters. Okay, now we could use the Pythagorean theorem, or we could use any other trig function. Let's just do the Pythagorean theorem. So, okay, well, let's write it out. So, Pn squared plus 124 squared equals P squared. So, we just need to subtract P squared from 124 squared. So, this is P. So that squared minus 124 squared, and then take the square root of that, 154.225. So N is 154.225 meters. There we go. We've solved the right triangle. We have all the angles and all the side lengths. Okay, so they're giving us these high precision. I guess the idea is like you can think about something was able to measure this angle with this amount of accuracy is like the idea, and maybe this length as well. But okay, so angle A is 90 minus angle B. So we can go ahead and do this. Why not? 1, 2, 3, 4, 68.514. 2. So 8, 9 minus 4, 5, 9 minus 1, 8, 9 minus 5, 4, 9 minus 8 is 1, 8 minus 6 is 2. So 21.4858 degrees. Okay, now let's do we wouldn't want to do tangent, right? Because we have two unknowns, but we can do the sine of this angle. So sine of 68.5142 degrees is equal to opposite over hypotenuse, 3579.42. So B is equal to, so sine of 68.5142 times 3579.42. 3330.68. Okay, and then A, we could just use the Pythagorean theorem or another trig function. So we've got 3579.42 squared, and then we're going to subtract, this was b squared, and then take the square root of that, 1311.04 meters. There we go. We've got all the side lengths and all the angles. Okay, here's a good example. We've got a triangle in kind of a weird orientation. So I've said many times that you can think about general 3D space, like here where x, the plane of your computer screen is like the ZY plane, but you could think about any plane in all of 3D space oriented in any way, and you could put a triangle up an upside down triangle. And you could solve this. It's the same thing. Opposite over SOHCAHTOA applies. Just do the same thing on any angle and Pythagorean theorem, and you could solve this right triangle, no problem. Okay, so we can start by just doing the Pythagorean theorem to get C, and you just remember that the hypotenuse is the side that's opposite the right angle. So C is the hypotenuse. So we've got 12.5 squared plus 16.2 squared, and that's going to be C squared. So, and we'll just keep, we're plus or minus, but we just keep the positive. So C is equal to 12.5 squared plus 16.2 squared, the square root of all that. So C is equal to 12.5 squared plus 16.2 squared, and then the square root of that, 20.4619 feet. Okay, now the angles, we can just need to get one of the angles, and then we can do 90 minus that other angle. So let's use tangent. Why not? Here we can use tangent because we'll say that tangent of B or A is opposite over adjacent. So opposite adjacent is 16.2 over 12.5. So B is going to be, we're going to input into the inverse tangent function of the calculator this. And it's going to give us an acute angle. That's what we want, though. Okay, so inverse tangent, 16.2 divided by 12.5, 52.346. Was it 346? Yeah. And we were in degree mode, so we got it's in degrees. Now we just subtract 90 from this. So 90 minus this is 37.654. And there we go.